At least in my mind, it's so much better than actual pumpkin pie. Okay. For those of you guys just joining us, the kids were writing down these 2 pages, the very last content of section 3.4, the homework that was due today. In that content, let me go to here. Homework 20 was what was due today, but I let you guys in the comment section, right? Just go up through number 31. Oh, weird. I guess we're a little bit, we have more than 4. Okay, yeah, a little bit more than halfway. I guess I looked at something else this morning with period 1. I don't know what I was looking at with them. Let me see real quick, because it looked way different. Oh no, it's the same. Okay, never mind. I was just making sure you guys didn't have like different assignments. Okay, so as we look at homework number, let's go back to the stream. Homework number 20. Now it's mad at me. Is this the right one? Yeah. You guys were able to get up through here just testing for concavity for the most part. And then for the latter end of homework, it starts asking a question right around here about relative extrema. Now, hold on. I want you to go look at forever card number 23 for me. 2 forever cards back, last section, 3.3. What was the title of forever card number 23? (23) What was 24 then?
24 was possible inflection.
Oh, got it. Go look at 22 then. Sorry, my bad. 22. I forgot we had 2 forever cards, concavity and inflection points. Ah, for what? Ooh. So there's a way to find relative extrema with first derivatives? Oh. And there's a way, look, forever 25, to find relative extrema with second derivatives? So the end of homework actually lets you choose, if I remember right, the directions. It says something to the effect of, maybe not all of them, but at least like the few in the next section of homework. It says something to the effect of find the relative extrema using the second derivative test when appropriate. So sometimes you're using the first derivative test? Yes, and we'll see that today. So not all of this is using the second derivative test. Some of it might be using forever card number 22. We're going to see that today. We're going to finish up 3, 4. There's not too much more to do. And as we've already talked about, isn't the hardest part of these homeworks probably the derivatives and the extra analysis on top of it? So you guys have already gotten the derivatives out of the way with homework number 20A. That's what we could have practiced with these ones, talking about how, oh, it's a gross derivative and a second derivative, but that's why you did homework 20A. Oh, it's a gross derivative, second derivative. That's what you did with homework 20A. Now, I do have your book technically open. I think I have it open to section 3.3. Sorry, that's the wrong one. I'm willing to look at any derivatives as you guys were grading homework number 20A. Were there any first, second derivatives or zeros, DNEs you guys got stuck on with simplifying? You can grab out your homework spirals if you want to look. I am willing to go over a couple in the sense of if you had the answer key in Google Classroom and you just couldn't make sense of it, it wasn't working out, you weren't sure why it was what it was. Because in homework 20A, I did put that answer key online, right? Were there any of these that you guys were a little stuck on? The end of homework number 20, oh, these ones, they don't need first and second derivatives. That's why they weren't listed here. Make sure you look at the proper homework number 20. But anything on the first, second derivatives or the pips? 57? Okay. Let's go peek at him. Anything else besides 57? Ooh, he's arcsecant. That's actually the exact same one that period 1 asked about. What page are we going to? 242? Okay, but as I pull that up, once you're able to get the derivatives and simplify, which we know can be tricky and can be hard, it's really just learning the procedure of what you're supposed to be doing. Are you supposed to be making a sign chart? Are you supposed to be analyzing for increasing or decreasing or concavity? Which derivative are you looking at? Which pitchfork, zeros, DNEs are you considering, et cetera, et cetera, et cetera. So, after I go through number 57, no other questions specifically? Okay. After I go through that, we're going to come back and finish section 3.4 and figure out what the end of the section is about. I'm going to be able to introduce section 3.5, and then I'll give a quick recap of what is needed, necessary for Monday when we get back for you guys not to be behind. I'm actually going to pull up the calendar also. It's probably the easiest way to show you guys what's going on. But long story short, remember, we have been behind, and to finish off the semester well, to finish it off strong, we need to talk about, ooh, that comes quickly. So here we go. Number 57. Where's my picture? Do we have a formula for arcsecant? Yeah, we do. I'm going to go up and take the first derivative. Arcsecant says 1 over the absolute value of u times the square root of u squared minus 1 times u prime minus 1. We could have gone about doing a common denominator, I suppose, and putting those together, but you guys realized for section 3-4 and for concavity, we weren't stopping at the first derivative anyway, though, right? Weren't we going to the... And what happens if you take the second derivative of a constant? Okay, so I'm not going to go through all the work of common denominators if it's just going to become 0 in the next derivative anyway. But the problem is, don't we still have to take this guy's derivative? Okay, we have options. What do you think? Quotient rule or making this to the -1 power? I heard both. Which one? Who wants to be stronger in their opinion? Okay. So I'm going to rewrite this as this, which is a product, right? Raised to the -1 power. Okay. I'm going to bring down the -1. I'm going to keep this to the -2 power, because I have to subtract 1, but what else do I still need? U prime. U prime. And U prime needs a product rule. Okay, well, for product rule, here we go. It's going to be messy. Can I erase the 0 because it's just a 0 anyway? Is that okay? I'm going to have second d first, which is just going to be the square rooty guy of x squared minus 1, struggle, times, didn't we write down absolute value as u over absolute value of u times u prime, which is just 1? Yeah, good. So u over absolute value u times u prime. So I did x over absolute value of x times 1. Plus, first, d second. Uh-oh, his derivative, don't we bring down a 1/2 and it becomes a -1/2? And you still have a u prime at the end? Sorry, that got messy. Let me rewrite this. So we end up with -1 over this guy squared times this guy, that's him, plus an x and absolute value x all over. Is there anybody that we can pull out? Oh, I can pull out an x. I mean, that's kind of shared. The will just be the expression left over. Absolute value of x squared. I can actually take out the absolute value. Oh, wait, but then I'm going to want to reduce. And I need it to be positive. Oh, well, actually, when I pull that guy out, he could be a negative, so I can just reduce. Okay, that's cool. So that's going to be a 1. In here, I have this guy. But you guys know that we want to get common denominators, right? We're trying to do derivatives simplified. So what am I going to have to do? Multiply this guy by that guy. Top and bottom. And multiply this guy by that guy. Now what? He's squared. Oh. So it's just him. An absolute value squared doesn't need the absolute value anymore. It's always positive. And that's still being multiplied by. I'm going to go backwards, but what I see now is 1x squared plus 1x squared is 2x squared times the 1 is just 2x squared all over. What's down there? Well, I guess I have an x squared minus 1 to the 1 and a half. 1 and a half, same thing, 3/2. And I have an x times an absolute value of x. Oh, well, I can take that guy away. Now, some of you might not have simplified this quite as perfectly as others. Some of you might have gotten really stuck in all those absolute values, and I understand. You might have not realized that an absolute value squared, he just says stay positive, but when you square him, he stays positive. So you can do things like taking out the absolute value sometimes. But at the end of the day, hopefully you saw, oh, wait a minute, minus 1. I didn't do minus 1, did I? Lo siento. Did I just not write him? I just didn't write him. 1x squared plus 1x squared is 2x squared minus 1. I'm sorry. I didn't write the minus 1. Which means I can't simplify the x. Thank you, thank you, thank you. I multiplied by 1. I didn't. Thank you, thank you, thank you. That was rough. That's killing a kitten now if I go canceling out. So that's just stuck. Okay. That's better. Whew. But our critical numbers, oh, no. Second derivative, our pips are going to equal x equals plus or minus square root of 1/2, I think. And then down here I see x equals 0 and 1. Plus or minus 1, huh? There we go. And that should match up. So great question. That was one of the hardest derivative ones. Oh, we had the lockdown drill yesterday. That's why we didn't do this example. I was thinking I'd already gone over it in period 1, and I had, but you guys just didn't have that extra time yesterday. Okay, with that, that brings us back to section 3.4 and how we're supposed to be using derivatives. Now, if you're a highlighting kind of person, you should be a highlighting kind of person. Grab out a highlighter, and I want you to make sure that you emphasize that relative extrema still only come from what? Relative extrema still only come from what? Critical numbers. If you go back and look at forever card number 22, it was the exact same thing. Both of them say I need critical numbers. And that's weird because critical numbers come from what derivative? The first. But what does this test say we're using? So confusing. You're not using pips for relative extrema. Pips are possible inflection points. The candidates for relative extrema are only critical numbers. So here's where it's weird. We're not doing a sign chart. First derivative test says, find the critical numbers, put them in a number line or a table, before, after, before, after, before, after. What's going on? Check the behavior. I have a string. Second derivative test says, no, there's another way. That sometimes, did you guys catch it? That sometimes works. Oh. But the second derivative test says you don't need to know before and after, you just need to know at. At a critical number, what concavity will f have? If f double prime at a critical number, it's weird, f prime, zeros and DNEs getting plugged into f double prime. But if f double prime is positive, that means that f is concave up. And if there's a critical number, smooth turn, concave up, what must that be? A min. If f double prime at a critical number is negative, that means that f is concave down at a critical number. And if there is a place, if there is a way for a critical number to be concave down or the function to be concave down at a critical number, that must be a relative max. Now careful, your brains are going to want to switch it. Why? Max with negative and min with positive, that's backwards. But if you think about concavity, if f double prime is positive, what's the concavity? Oh, it has a min. And if f double prime is negative, think of the concavity. Oh, it has a max. So your brain's not going to like it because of this. But if it thinks about this, you're okay. So on this test, it's very possible some of you guys are going to be doing this as you're trying to do problems. And that's okay. I do it. When I'm grading, I'm like, wait, So the process is actually pretty basic, except it's like the sign chart for f prime, which is weird. It's the second derivative test, but you use f prime because you're looking at discontinuities. And Here's where it gets weird, and if you still have your highlighter, highlight this. For the second derivative test, we're plugging. We're not doing a table. We're not testing before and after. We're taking the critical numbers and we're plugging into F double prime and checking the concavity. If there's concavity, it will tell me max or min. And if there's not concavity, could still be a max. I have to go back to the first derivative test. Is there a change in increasing d? Could still be a min. Could be a neither. This one, F prime doesn't exist, F double prime doesn't exist. This is neither a max nor a min. You wouldn't know, though, because there's no concavity at the point. It's a point of inflection. It's in between concavities. It will just not work. It's going to be like a 0 or a DNE. I go to my first derivative sign chart and see decreasing to decreasing. I'm like, oh, yeah, nope, he's nothing. He's not a max or a min. So this test is great if you get a positive or a negative for a second derivative. And here's another, it's great. It's great to try to use it if the second derivative is easy. Did you guys find some second derivatives that are hard? Use the second derivative test for me. I'll use the first derivative test. And you can do that if you're looking for extrema. But why would I say this is a pretty good one to do the second derivative test on? Besides the fact the directions say use the second derivative test. Struggle. Done. How hard is it to go from one derivative to the next to the next to the next of this guy? Hopefully not that hard. You don't have any product rules. You don't have any quotient rules. Do you have a chain rule? Oh, come on. There's a Matryoshka right here, right? But too bad. You guys see why? Hopefully the first derivative is 2 cosine x minus 2 sine 2x. Ooh. You see it? Derivative of cosine is negative sine of u times u prime, right? Okay. How hard is it? Derivative of 2 cosine is negative 2 sine. And derivative of negative 2 sine of 2x, well, the negative 2 can stay. Derivative of sine is positive cosine. That just stays the same. Times 2x times, ooh, another chain rule. So instead of 2 cosine 2x, it's going to be good. That wasn't so hard. There's that second derivative. But why would you do that? Well, we're being asked, they're asking us to find the relative extrema. Relative extrema, do I find zeros and DNEs of this guy? No. I find zeros and DNEs of this guy. So careful. Even if we're going to use him and plug into him, we still have to go here. Now some of you are like, well, how do we do that? It's trig. Do you remember this is a forever card? Isn't he a double angle of sine? Isn't he 2 sine cosine? Oh my goodness. So 2 sine cosine, does that help anything? The answer is yes. Because can't you factor? And what happens when we factor? Okay, second derivative wasn't hard to find. We had to come back up here, numbers, but now we can pull out a 2 cosine x and we get 1 minus 2 sine x. This is looking awfully unit circle-y to me. How about you guys? Set that guy equal to 0, set that guy equal to 0. Our job today is not to review the unit circle. Maybe it should be. Cosine will be 0 at cosine 0 at pi over 2 and 3 pi over 2. Okay, we have to take those. Sine is, have you guys done the math? Minus 1 divided by negative 2. Sine is 1/2 at pi over 6 and 5 pi over 6. I don't need to go any farther because my interval just says 0 to 2. These guys are my crits, right? My critical numbers. Who are they? The candidates for relative extrema. Are they? Let's do a sign chart. 0 to this guy to that guy, that guy to that guy, that guy to that guy, that guy to that. Let's plug in for every single interval a unit circle value and check the sign. That's the first derivative test. Do a sign chart and check what's going on in between. analyze. Second derivative test says, bring me your tired, bring me your poor, bring me your critical numbers. And plug them in. I don't know if it's tired or if it's weary, either way. Statue of Liberty. Second derivative says, no, bring me these guys. Plug them in. Let's see if there's concavity. And if we know anything about trig, guys, is there concavity? Yeah, there's no sharp points or anything weird like that. So what do? We say, hey, what's f double prime of pi over 6? What's f double prime of pi over 2? What's f double prime of 5 pi over 6? What's f double prime of 3 pi over 2? Now you're going to have to be plugging into trig no matter what, whether you were doing a first derivative sign chart or whether you're doing a second derivative test of plugging in. You're going to have to plug in no matter what. Just this way, you actually don't have to plug in as much. And when you do plug in and you get something like, oh, stink, I have to do trig again, plugging into him. 2, sine of pi over 6 is 1/2. Minus 4, cosine of 2 over 6 is pi over 3. Square root of 3 over 2. That's a negative and a negative. Oh my goodness, that's a negative. But what does that mean about f? Concave. So what must this guy be? A max. This I can attach to that, which means he's a max. Why? Because he's a critical number, and the second derivative is negative. Dun, 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 dun. And that's what we're going to do for him and him and him. Plug in and say, what's the concavity, positive or negative? The concavity, positive or negative? 2 times pi over 2 is pi, which is negative 1. Oh my goodness, a negative plus 4, that's a positive. So what's f's concavity? Yeah, base up, which means I have a relative min. And just a quick heads up, as we keep on going down here, kiddos, after you do the work, if I remember right, this guy ends up being a negative. This guy ends up being a positive. We have another max and another min. And if we were to justify, we would use the forever card. Check out the end of the video to make sure you have Thanksgiving break homework. We can say, oh, hey, we have relative maximums at and relative minimum. No, we have multiple at. And we could say the x value where the concavity was, well, max down pi over 6. And down 5 pi over 6. And up pi over 2. And up 3 pi over 2. But wait, I had someone ask me a question yesterday, and it was a really good question, because I've been showing you, give me the x where this is true. And to some extent, that's homework, but have you guys seen any homework where they ask you not just for the x, but for the ordered pair? Have you seen any homework? They're asking you for the whole point and not just the x. If they wanted the whole point, I have an f. I have an f prime. I have an f double prime. Someone help me, please. Where do I find my y? I have to go f of a. To find the y value for an x value, if they did want the point, I would need to come from here back to here and say, okay, these are my x's. What are my y's? I don't know. I'll go plug in. But y's always come from the original. Now, kiddos, what if I was to... hey, why would this be a good second derivative test function? Yeah, getting to that second derivative is fast. And as soon as you get to the second derivative, well, first you have to actually remember, get to the first derivative, find the critical numbers. But second derivative test says, bring them to me, plug them in. Is there concavity? If so, yes. I can tell you who everybody is. In a polynomial, it's going to be easy. Polynomials have maxes, mins. Nothing crazy is going to happen. Second derivative test is going to pass. But in homework, might you have some functions whose second derivatives are gross? So maybe you might just choose to do the first derivative test and be like, I didn't like the second derivative. I'll just remember that should have been a first derivative test person or function. But the second derivative is easy. Go for it. Now, coming back here. Do you guys recognize why this is a tricky problem? You should homework spiral right now. Graph of f prime. Oh, struggle. If it's a graph of f prime and I'm trying to think about f, where are my crits? The zeros of f prime. And isn't this my f prime? Who are my pips? The zeros of f double prime. Well, the zeros of f prime, that's not too bad as long as you guys remember from our homework spiral. Won't that be -1, 1, and 5? And we can make a sign chart and think below, above, and we can think of the signs of f prime. But my pips, how do I think of f double prime if this is f prime? F double prime is the prime of f prime. Wait. That makes sense. And it's the prime of f prime. Derivatives. Oh, so when are the slopes 0? What's new? -1, but also, ooh, who is that guy? Like 1/3? And then, who's that guy? 3? Look at when the slopes are 0. What do I do for a chart? I think about the slopes for the sign of f double prime and say, what are the slopes to the left of -1? The slopes are up. Oh, the slopes go down. Then the slopes go up. Then the slopes go down. That's how I think about f double prime. He's the slopes of f prime. Kiddos, this is the end of section 3.4. Let's check out the end for. This is the end of 3.4. Before I go and introduce section 3.5, even though you're going to be able to listen to me on the videos, on the Google Classroom assignment, let me show you what I mean by spring break homework. First thing, spring break, sorry. In calculus, the break homeworks are almost always very similar. This is the first year where the breaks homeworks are going to be really weird. So in my head, I'm always like, break, spring break. No. Thanksgiving break. Okay. Almost always, the break homework, I give you a form and I say, quote those forevers. We have a huge cumulative forever quiz the day we get back. That's almost always every single Christmas break, spring break, Thanksgiving break. This year's weird because we didn't finish chapter 3A. So instead, we're not having a huge cumulative forever quiz on Monday. We're having a chapter 3A forever quiz on Monday, okay? We're not having, sorry, you guys see lots of different things up here. It's not just your class, it's all my classes. But we're having a forever quiz on Monday. Just cards, if I'm not mistaken. The last quiz was 16 and 17, I think. So 18 through 25. Now, are those a lot to study? Yes. But I'm telling you right now, the bonus on the forever quiz is having your cards updated and in class. Nice, right? The bonus is having the cards updated and in class. So there's a forever quiz on Monday. Study your forevers over break, however you choose. I'm not going to dictate, even though the rest of the breaks I dictate how you study. For right now, just study the cards for the chapter, okay? What else is due on Monday? Uh-oh. Due. Homework 21. But we still need to finish homework 20. Well, didn't you turn in what you tried for today this morning? Okay, so you need to finish that up. The quicker the better, because we just finished forever card 25. Like, okay, I can go find specific extreme using the first derivative test or the second derivative test. Finish that up. I'd say tonight, tomorrow, get it out of your life. Section 3.4 done. What did I tell you about 3.5? Well, pause. First of all, in class, what we're doing is questions on 3.4 and 3.5 because you're finishing him up. No new Google Classroom submissions on homework 20. We've done enough of him already. But 3.5, oh no, that's okay. Let's go look at Google Classroom. Google Classroom, what I have in there right now, and I tried to have it ready for you guys, is homework 21, whose directions are the following. Whoa, there are videos attached? Videos of me teaching? I've given you homework number 30, but what I've told you first is to watch the videos below. 3 videos? Wait. I say don't start until the end because we did like some homework questions on 3-4, which maybe some of you want to watch. But the end of this is where I started section 3.5, and then I did most of section 3.5, and then I did a little more of 3.5 AP practice. Like this is like a lot of going further deeper. This is the main one introduced in that one, okay? So when you watch the first 2 videos, the end of the first and then the full of the second, and if you need to, you can keep on going with AP practice, etc. with the third. You're working on section 3.5 coming Monday with questions. Now 3.5, what is it that I'm not too scared besides your lack of motivation and procrastination, which I'm always scared of? I'm not too scared that you guys can do it. P.S., going back to our calendar really quickly, why am I pushing this in? Because this test that's now on next Wednesday, next Wednesday, was supposed to be today. Actually, yesterday. So I'm trying to have us not be too far behind and catch up a little bit before the end of this semester. So the test is coming. The test review, book review, is going to be due on Tuesday, so some of you might be able to work on that over break also. I'll put it on Google Classroom, but the deadline isn't until Tuesday. And then there's going to be a bonus practice test like normal for Wednesday, okay? So coming back, why do I think section 3.5 is something that you guys don't totally, homework help. I need to move that out of the way. Need me for. Remember how at the beginning of chapter 3, I said something to the effect of, this whole chapter 3a, analyzing functions, is for the purpose, or at least one application of, getting to the end and being able to take any function and graph him with all of his particular characteristics and behaviors identified without a calculator. Now up here, if you guys notice, I have the first derivative written and the second derivative written. Why? Is the point of 3.5 that you can take derivatives? No. The point is that you can use them. So we've already with derivatives simplified, etc. So some of you guys might want to do a worksheet like we did with the other homeworks, derivatives off to the side. I'll probably post in the Google Classroom the answers to the derivatives for this homework also, so you can take derivatives and make sure you're right before continuing on. But what I like to say is, basically, if you can find 14 things for me, you should be able to get his graph perfectly. But some of those 14 things are actually from like Algebra 1. Or maybe from like Algebra 2, vertical asymptote, horizontal asymptote, oblique asymptote, holes, symmetry domain. But this is all like, let's just get some of the core stuff figured out. And then it's like, no, but we're in calculus. We can go further. We can to figure out when it's increasing, decreasing, to find relative extrema. We can figure out pips, identify concavities, to find points of inflection, and then we take all of this into a graph and say, okay, let me just start putting the points. Let me start putting the vertical and horizontal asymptotes. Let me start figuring out how it's moving, and then, haha, my graph. That's what you guys get to play with over break. But what are you practicing when you do this? Kind of all of chapter 3, and kind of chapter 2 with derivatives. Kind of everything. Bye, guys. See you later. If you need anything, if you have any questions, email me. But tell your padres, tell your amigos and amigas